my name is Erik Hatcher, and I'm doing a talk on Solr indexing and analysis tricks. Just some things that we've culled together, just kind of playing around with this stuff for customers and so on. So, just a quick bio. I'm a Lucene Solr committer, co-author of the Lucene in Action book, and a handful of other things out there. But let's go ahead and jump into the meat of this talk here. This came about from a customer of ours asking us to add entity extraction to their Solr instance, basically. And as we discussed with the customer what they actually wanted, several very lightweight things kind of came out of it. They thought they needed a very heavy-duty entity extractor, commercial products plugged in, and so on. But they said, well, we want acronyms extracted. What's an acronym? Just 3 plus all caps, maybe dots in between type of expression. They also wanted key phrases out of the documents to be extracted so that they could facet on that. Just a phrase that is very common across their documents. If a document contained that phrase, they wanted that to be a facet on it. They certainly had other more sophisticated needs in terms of recognizing people's names and places and some other things like that. But what I'm going to talk about here is the lightweight, kind of low-hanging fruit capabilities that you can get out of this. And so as I did this and distilled some of these tricks here, I wrote a blog post. So and this session is going to show you what I did in that blog post and then kind of talk a little bit more about what we did there. So as I was crafting the blog post, I wanted to detail how we extracted acronyms and key phrases, but also I came up with examples for extracting some other things, URLs out of free text, loose text, and also locations. And again, it's very kind of simple patterns that we're doing in here, but it certainly could be expanded to be richer there. But extract out things that look like lat long coordinates out of text. So the example text that I used for this demo is a little bit different than what I put in the blog post, but I wanted to put some kind of relevant for the locality here, is just this. It's just a text file that literally has that in there. And after all is said and done, that processing, it comes out like this. And this is the browse request handler in Solr, where I extracted out the acronyms there, extracted out a key phrase. I had airport as a key phrase in there, and also extracted out the URL as a link, and extracted out the location that's in there. So you can see the various kind of entities that are in there, the acronym, the lat long, and the link, and that kind of stuff. So that's the end result that we're going to develop through here. The techniques we employed, well, let me first talk about some of the challenges here when it comes to analysis and query parsing. So this is kind of a step back from that actual example, but it's something that I see a lot of confusion, or it's a little bit fuzzy about what happens during query parsing and analysis and how those two things work together. So as you extract these entities, you're going to have to be aware of how you could use those entities also in query parsing. So I just want to point out that analysis and query parsing, they're certainly not at all equivalent. Query parsers, as they operate, will generally, not always, depends on the query parser, will analyze chunks of the query independently and then piece together back the tokens that they get back from that analysis into a more sophisticated query. So depending on the query parser that you're using, that query parser will then analyze each of the various chunks. If you say A and B, and you're using the Lucene query parser and you've used capital AND, it will analyze A, and it will analyze B completely separately, and then combine the two back into a Boolean query with those two terms ANDed. But what I see people do a lot is use the UI that's within Solr's admin in the analysis, and they'll kind of put the query in there. And if you've got that and in there, it's just sending that exact text into the analyzer, and the tokens come out of that. It's not doing query parsing. It's only doing, if you were going to use this to kind of troubleshoot some query parsing issues, you would have to know how the query parser worked and only put in the pieces that the query parser is sending in there. So just some things to keep in mind there. And here's some examples here. Lucene Revolution in Dublin, and I believe that's the Gaelic form of Dublin. And then whether you put Lucene Revolution in quotes, or you use Lucene and or Revolution, all of those things do different types of, they'll generate a different type of query at the end. And obviously the query parser configuration is going to be relevant here. Which fields are you querying across, and so on. So as you can see, that top expression, in fact, just that very top expression, because I've got a synonym in there for that version of Dublin to the Dublin that you see at the bottom there, using the edismax query parser, that's the expression that comes out of that. So just wanted to kind of distill any myths that there are or confusions there might be in terms of query parsers analyze. Very kind of tricky synergy that has to be in there to make it all work right. So the first step here, the first example, is going to be extracting acronyms out of the text. Now, I'm doing this by taking the content field, because it's a text file. I'm using the extract request handler. I'm sending that text file into Solr, and the content field is what Tika, what the extracting request handler, hands as the field value to the content field. I use Solr's copy field capability to copy the content into a field called Acronyms, and that Acronyms is of type caps. I defined a caps field type. One thing to note about copy fields is that the destination of a copy field generally is not something that you need to store, because you can store the original value and use that, but the destination is something that you're going to index in a different way. And in this case, because we're going to be pulling out the acronyms, we don't need to, if I had set that field, that destination field, to be stored, I would be storing the exact copy of the content, the full text of the content, in two different fields. Even though the term that comes out of the analysis process is just going to be DUB, the stored value will be the original content that you fed in there. So be careful with this copy field stuff, and cautious about what you're storing there, and only store, really only need to store one definitive version of a field there. There's a very nice token filter that comes with I forget exactly what version of Solr, but it's a fairly recent addition. Solr 4.5, maybe 4.4, is the pattern capture group filter. This pattern capture group filter allows you to specify a regular expression, and it will capture those groups and output them as tokens. Now, there's other regular expression capabilities in terms of analysis where you can replace things in regular expression, but this one allows you to grab a piece out and emit that as a token. So what happens when you pass the text through the pattern capture filter here, and you can see the pattern is all caps, and an optional dot there. The backslash dot is a period, so you can do I.B.M for IBM. And then the 3 or more is the curly bracket 3 comma. And so that's the pattern I use to extract acronyms there. Another note here is that these results of this analysis process, these are tokens that are indexed. They are not the DUB that comes out is not a stored value inside of the Lucene index. It obviously lives inside the Lucene index, but as an index term, but not as a stored value. So you can't simply retrieve it back when you get your results back. You can't put it in your FL and get it back. However, you can use index terms for faceting, for searching, of course, and if you need to use it for boosting or any types of indexed operations there. but again, not stored. Okay, we'll get back to that stored issue in a moment. Okay, so extracting with the copy field there. Now let me just go over here to some demos here and show you what we've got set up. And first I'll start with the example data. I've got a little script that will let me increase the font size here. I've got a little script to load that data, and that thing simply post to update extract to this example data text file. That's how I'm getting the content in. I've got a schema, and big there. My schema has an acronyms field right here. That acronym field is of type caps, and right here is my caps field type definition. I'm doing keyword tokenization. Now this is an important thing here. The keyword tokenizer emits the exact value that came in as the token that comes out of it. So similar to a string field, except that it allows me to specify more steps to operate on that. So basically the full text is coming out and being fed into that pattern capture group filter. And it's simply this. If I had tokenized, then I may have lost some information there that made the acronym an acronym. If it had tokenized and removed the dots or had lowercased or something like that, then I would have lost the ability to pull those things out. Okay, so that's an important feature there. And let's see, over here in this is Solr. I've added a few templates using the velocity response writer here. So I've got a neat little UI here. Let me grab that text so I'll just grab just kind of this part here and paste that over into this text box. And when I submit, what it's going to do is run that text through all of the field types that are defined in my schema. So it's a very simple little velocity template, just introspects Solr, finds out all the field types, and then uses a little jQuery trick in there to render each of these with all of the various field types. So you can see my caps field type is defined here, and the only thing that comes out is that. I made a little hyperlink here so it goes over to Solr's analysis with that same data, and you can see the keyword tokenizer, that's this guy, emits the entire text, but the pattern capture just pulls out the acronym. So pretty straightforward stuff there. Again, lightweight way to pull some neat things out. Let me now show you the keep phrases feature in here. So I have another field defined as key phrases. It is of type key phrases. And over here, you can see I'm actually, this is the copy field definition of the acronyms and then of the key phrases. And in the key phrases field type, I'm actually using the standard tokenizer here. And then I shingle, and I'll explain why in just a moment here. I shingle the output of the standard tokenizer from 2 to 5 word groupings, and this would be the number of words that were in my phrases that I wanted to pull out. And then I use this interesting filter here called the keep word filter. And what this does is it only emits tokens that match text that or lines that are in this keyphrases.txt file. And then I simply lowercase those. And that keyphrases.txt file looks like this. And so the only relevant one for this example data is airport, but had I had other points of interest in there and so on, then it could have extracted those and made those facets as well. So what I get when I analyze that text. Let me copy a little bit more. Well, actually, that same text will work here. And if I back up and go back to my analysis, you can see the key phrases given this text only extracted out airport. And again, I can click over here and go to the Solr analysis here. It tokenized that full phrase. Sorry, it's kind of scrolls across here, but it tokenized with the standard tokenizer. That full text, and then the shingle filter here shingled the various words. Then the keep word filter only kept words airport, toy store, and restaurant. And then, of course, lowercase, then the token is way over here in this UI. And the way I rendered this stuff in this UI here is I simply passed this information into a request handler that Solr has built in called the field analysis request handler. And I just pull out the last tokens of that whole chain and display those. And I'll show you a little bit about that again, because that's a neat feature to be able to use tokenization and the analysis and the field type definitions externally to Solr and be able to pass a string into Solr and get back the results of the tokenization. And maybe you need to use that in your client app for other purposes. So that's another interesting feature there. So those are the two kind of very simple ones where I can just copy field into a field type that masks out and just gives me back some things there. So obviously acronyms and the key phrases. So as we talked about just now, the one of the negatives, I guess, or one of the issues with doing this stuff as a copy field and so on is that the stored value is basically worthless when it comes to that, because you've already got that. You're copying that stored value into another field anyway, and all you get out are the tokens. Again, useful for faceting, useful for boosting or searching for those things, but not as getting that information back on the documents themselves. So the next thing I'm going to show you is using a feature of Solr called the script update processor. The script update processor, update processors in Solr are the mechanism to, as content comes in, it goes through a series of steps of processing, and then the output of those steps is the document that then gets handed to the analysis chain and so on. But you have the ability within Solr to do manipulations that affect the document in various ways, as if you had sent the document in, done the manipulations outside of Solr, and then fed it in that way. But you have the scripting capability in there. There's many other update processors that are now in Solr to allow you to mutate field values and so on. And again, the results of that are basically the stored values that you're feeding into Solr. So now you have the ability to mess with stored values inside of this script thing. And so the way you do this is in Solr config is you define an update processor chain. There's already one built into the example Solr configuration that's called script. It's not used anywhere unless you say use this. And then there's an example update script that's there. So you can simply just say, as you see right here, say update chain equals script. If you're using the Solr example configuration and you've got all those files there, then you can use the script update processor by just specifying that. And you can specify it with post.jar if you're just posting things in using the lightweight post tool from Solr, or on your URLs as you're posting in, or you can set the default chain to be the script, the one that has the script in there, so that it's always, all content comes in, comes that way. So you have the ability from the outside to say which update chain you want to use if you want to have different kinds of ones there. The script update processor allows you to use pretty much any JVM scripting language out there. The example is in JavaScript. but you could use JRuby or Groovy or Jython and other languages like that. I've kind of played around with each of those to come up with an example. But the JavaScript one's built into all JVM, so it's very easy to use that without having to add in the other scripting engines. So what I want to do now is, in this example, is I've got a lat long in that text. I want to match that lat long, extract it out, and attach it to the document in a separate field in a stored value kind of way. And I want to use a field type that is suitable for geographic and spatial search. I'm not going to go into any details of the geographic or spatial search stuff, but as I extract this, now I've got a rich try-based field that allows the geo search capabilities there. And the code that does this is basically right here. There's a pattern that matches number comma number in a lat long looking format. And I haven't shown you the get matches method there, but there's a get matches method in the script that just basically uses that regular expression against that content and pulls out the matches and gives you back an array of strings at that point. And then I set the field value here within the script, and voila, I've got now this extracted locations field there. So let me just show you what made that one tick. So first of all, I'll show you Solr config, the update script here. So this, I don't think I changed this at all from the Solr example. This stuff right here, I just target this particular update processor chain, and then it says update-script.js. Here is this update script. You'll see that there's let me just give you the high-level view of what the script has to contain. An update processor has, in Java, has many methods. These methods that you see right here, process delete, these types of things. Really, none of this stuff matters when I'm adding content, but you have to have these methods defined in there, and you'll get an error. So there's a lot of no-op functions that are in there. But the heart of this thing is this process add method. It hands you a command. That command is, I think, an add doc command or something like that in Solr. So to get the document out of that command, I just get Solr doc there. And you can log things to Solr's log from within the script. I'm getting the ID here and then logging the ID out when I index. You can get any of the incoming field values here. That's obviously quite important here because I need to pull some things out there. And then here's what I just showed in that slide: the location regular expression, extracted locations calls this get matches method. I'll show you in a second. And then I simply add that to another field. So manipulating the document here, I could remove fields, I can add fields, I can change field values. I have full control over that Solr input document before it really hits the Solr update processing and does all the analysis and so on. So let me show you the get matches method here. You can just kind of ignore the stuff at the bottom, but for now we're looking at this one. And very simply using JavaScript regular expressions, exec the regular expression, pull out the capture groups here, and return that array. It's just an array of strings. It's very simple there for that thing. And that gets fed back into Solr here, and it shows up. Now this one shows up as a stored field, and that field type, let me just go bounce over to the schema and show you this field type here. So I've got extracted locations. It is of location RPT, and location RPT is defined as this recursive prefix tree field type. That is Solr's geospatial thing, and it just takes in lat long string as its input, and then does a lot of kind of magical indexing there to allow it to be geospatial searched. The next example that I want to show you that comes out of this script is pulling out URLs. it's exactly the same thing. So I'm going to kind of go through this one, breeze through this one. Just another regular expression. I'm looking for HTTP or HTTPS. It's probably not a very robust regular expression, but it pulls out the link that I have in my example here. And I simply call that get matches again. And in my output here, I have the link extracted and attached to my document. Okay, so that's pretty neat little tricks there to pull stuff out through the analysis chain or use regular expressions in the update script processor. Any questions about any of that so far? Yeah.
Is there any reason you couldn't have done the acronyms here?
I could have done the acronyms here. However, yeah, I could have done the acronyms here with the regular expression. Sure. There are, let's see, is there anything that I couldn't have done here? Well, what I'm going to show you in a minute is how you can actually use this analysis stuff within the script as well. So I can call out to an analyzer because in my script, if it's not necessarily comparable because I may be tokenizing and so on. With the acronyms, I use the keyword tokenizer. So basically, I'm just having a full string to a regular expression matcher. That's all. But if I'm using in fact, for the key phrases, I couldn't have done that as easily in here because it's not regular expression matching. It's using the keyword filter. It's using shingles to build up multi-word phrases and so on. So you can do simple regular expression stuff like that, but to use the analyzer, I'll show you how to do that in just a second. Any other questions? Yeah.
The keyword filter, how many keywords can it handle in a text file before it starts to run?
Well, the keyword, let me pull it up just so we have it in front of us. The keyword tokenizer here. Oh, I see. I don't know. I'm not really sure what the limit would be. I mean, the same as kind of synonyms and all those types of things. I mean, you could certainly envision it having a kind of a massive file. But the idea is that in this case, the customer they just had a handful of kind of important phrases that were across their financial documents, and they wanted to just have those as facets and to be able to let people just click on it. Of course, they could have searched for those phrases and found them. There's other techniques they could have done as well in terms of using facet.query as another technique that they could have done without extracting those things and faceted by queries that matched phrases. So that's another technique that could be used. Let's just see what's next slide-wise here. The next one here, let's pull the slide up first, is to use this analysis chain inside of the script. Sometimes you want to be able to leverage the richness and the power of all of Lucene and Solr's tokenizers, token filters, and so on. There's a lot of really great stuff in there in terms of, and we probably, many of you already know the types of things that can happen in there where you can normalize international characters, diacritics, tokenize Japanese very richly, and all those types of things that you wouldn't want to duplicate yourself outside of this environment. But you can leverage what the power of this analysis chain in other contexts. And this context here is within this script update processor to be able to run the analysis chain, get the tokens back, and then use those tokens in some way. In this example right here, it's just taking that array of strings of tokens that it extracted and then handing them right back as a string field here. To do that. So let me show you an example of that. I think I have it commented out in the script, so we'll just have to rerun the indexer there. So right here, I've got what I just showed on the slide, this particular code. So let me just uncomment this, and we'll just see what happens. We might want to tinker with the field type and that sort of thing. So I'll just run my load again and now refresh this view. And what you can see here is that I now have this field that includes synonyms. This was done at, again, at the script update processor time. If I had done this just through standard analysis, the stored value would have been the full string again. But in this case, because I added different types of stored values, I added actual tokens that were individual strings here. You can see that it tokenized it out using the field type for this. Actually, it tokenized out using a different field type, but added as a string field type, a multi-valued string type. That's what the SS means, is multi-valued strings. And each of those tokens came out as separate things. It actually also did synonym lookup here because I have a synonym from airport to aerodrome in the synonym file. So that came out of that analysis process, again, in the script. So let me just show you how that script gets put together here. Actually, I think I have it on the slides, so we'll just go back to that. So the one missing piece here is, what is that get analyzer result doing? And that is this right here. This is using Lucene and Solr's APIs within this JavaScript environment to call out. It gets the analyzer from a particular field type that gets passed in there. You can see the analyzer got pulled out right here. I'm calling out to the schema, giving it a field type name. I've now got the Lucene analyzer object back. I hand that into this get analyzer result, and I simply walk the token stream and pull out each of the tokens and return back, again, just an array of strings, but they're the individual tokens that came out of the analysis process. And so, let's see, is there anything else to talk about here? Does that make sense? Everybody okay with that? Fairly straightforward, but it's kind of turning it around, and you're doing the analysis yourself in there. Why would you do this? I don't know. We could dream up various use cases, but you know, you can do this. You could do, you know, kind of matching in here to specify how something matched and so on, and do that, you know, basically in a script at index time. So the one other place where we might want to use this analysis chain is just externally. Maybe you want your client app to take a string value, hand it to Solr, and have Solr give you back the tokens. And as we've seen, Solr includes that capability simply through the Solr admin. So I can go through here and go to analysis and pick right, and I can do this kind of stuff here. And the way this is working is it's calling out to this request handler inside of Solr and getting those terms back to the UI and displaying those types of things. And that's the type of thing that you can do externally yourself. And I think I have an example of that already up here. And I can do this in, you know, I don't know whether XML or JSON is a better way to look at this stuff. But what I've done is I'm passing, I don't know if you guys can see that URL, but let me just copy it and break it down for you. So Solr slash, you know, collection one analysis field, right? So I'm calling out to the analysis slash field request handler. I'm passing it a field value, and I'm passing it the field type that I want. And of course, all this other stuff doesn't matter at this point, but this is the heart of this right here. And what you get back is the output of all of those various tokenizer and token filter chains, and you can, if you're processing this stuff in your client app, you may not care about all of the intermediate tokens that are there, but they're there in this response for you. You may just want to peel off the last one here, and I passed in this text right here. I've got that synonymmed in my schema. Let me just show you that as well, so we can see that. So in my schema, I've got a field that is called a field type called just synonyms, and that keyword tokenizes, uses a synonym filter, and it also whitelists out only. This is another interesting token filter in Solr and in Lucene, a type token filter, and you can whitelist or blacklist, depending on how you set this flag here, out various types. Now, oops. That says we're getting close. So I can whitelist or blacklist out these tokens. There's a separate file here that tells me the token types that I want to extract here. So when Solr is running its analysis, what happens is the tokens that come out of the token stream have a type. Generally, tokens have a type that is of type, let's just see if we can pull this up a little easier here. Right here, we'll just look at kind of the general analysis here. What you'll see is that these types, the tokenizer created these various types, and it just puts literally a string called bracket alpha num here. When it hits a synonym, the synonym filter outputs a type called synonym. So you have the ability to, as long as your tokenizers and token filters are attaching types to these. Now this information is not indexed. This is purely a token streaming kind of metadata that's happening in there. There is a token filter that can take the type and turn it into a token itself. But that's not something I'm covering here, but you can turn that around. But you can whitelist out these things here, and that's what's happening right here. And I've got this token type whitelist file, and it literally just says synonym. So that is why what comes out of this analysis here is simply the synonym for that. So I passed in. Let me just come back to this. I passed in the Gaelic form, but it went through my synonym filter and gave me back Dublin. So that's that trick. So we want to be able to leverage this type of thing from our own apps, and you can already see there's an HTTP API. I can pass text in and get this stuff back. And I simply have a template here. So if I take off if I change this to velocity for the writer type, I have a simple little template that peels off the last tokens that come out, and I'll just show you that template there. It may look a little hairy, but not too bad. So what analysis? Okay. So it simply says, forget this hyperlink stuff, but it's basically a for each over all the tokens, put a bracket around the token text. All right, looks a little ugly, but it's a very simple template to be able to do. That's what powered this whole thing. Each one of these is calling out to that little template to generate the results there. Okay, so that's what we just went through is what happens and how you can use this externally. And maybe you have some use cases where this would be a useful technique. And I was asked to put this thing into the slides, so hurry up, tweet it, win something. And that's the end of my slides. Questions? I can't see you, so just shout out. If you got some questions here. Let's wait for the mic here.
So if you've used the scripting process, and you said the output of that is you're generating effectively new fields in your input document. So if you've used the analyzer there, the output will then be effectively still reanalyzed using whatever types you've then.
It would. However, in this example here, I'm calling out to a particular field type here, but I'm sending it into a field called this, include synonym SS. Now in my schema, that field type, it's a dynamic field type definition. It is of type string and multi-valued. Okay. So it's just strings at that point. There's no actual analysis. Now, if I had fed that back into a tokenized field, then I would, be tokenizing again in some way. And, maybe there is some wild and crazy idea that would be useful. But generally, if you're tokenizing somewhere else, you want them to just basically be index strings when they're inside. Sure. Unless they're maybe numerics. If they're numerics, then it could be a numeric field type, right? So that could be a useful one. Say that again. If you wanted to do query time tokenization, well, one thing that I've seen as a nice use of this type of thing is, sometimes the client wants to generate the queries in a richer way or a different way than maybe, say, the query parsers would do it. And so you could call out to the analysis, get those tokens back, and then fabricate the query with those tokens. If you're using the surround query parser, for example, it does not do analysis. That's a pretty niche query parser, but it has a lot of power in there. So if you need to analyze your tokens to use the surround query parser, you could do this externally and then piece together the surround query syntax with tokens that you pulled from Solr's API. Yeah. You want to wait? Let's wait for the mic. Sorry.
One of the things that's really useful sometimes is being able to put tokens in the same position. So I was curious, how would you kind of manage the position increment?
That's a great question. Andre, is he here? He was here in the last session. There is a pre-analyzed field type. So, and it takes it's got a pluggable kind of way to represent the pre-analyzed tokens, but basically there's a JSON syntax, and I think there's another lighter weight syntax, textual syntax. But you could create that JSON and feed that into Solr, and it's already tokenized, in that JSON syntax with the positions and all the attributes and so on. And then the pre-analyzed type will just feed it in that way. So you could use that. Anybody have any interesting use cases that this could apply to? Any clever tricks that you could see? Nobody wants to admit to it. Yeah.
So this is more of an architecture question. For some of these, especially the things like the regular expression matching, what's the advantage of doing it on the Solr side versus doing it in whatever application is sending the data? Or maybe you can talk about customers and if is there some divide where it would make sense for some customers to do it on one side versus the other?
Yeah, good question. I mean, I'd have to take those on case by case basis. I haven't actually encountered a real world scenario where I needed to call analysis and then rebuild the query, but we certainly have kind of situations where we border on that being a useful thing. So, and you certainly can use, and this is maybe bigger than just search, or it's a kind of a niche thing, but you certainly could just use Solr as a way to tokenize things and hand stuff and get the results back, right? You can do that with the extracting request handler, for example. You could feed a PDF into Solr, not actually index it, but have it parse the whole thing for you. So you can kind of use Solr as this engine to do these things for you. Right on. Yep.
I was just going to say, we actually do that, for the Drupal integration for attachment extraction, because it lets you just easily toggle between using Tika locally in Solr.
Right.
Because
Because you got two different update handlers that you're calling into. Yeah.
Right.
Yeah. Understood. Thank you very much.